Hi, so for this video we'll discuss one of our favorite chemical reactions, and it's combustion. And if I say combustion, all of you guys think of fire, and yes, it is fire involved. But we're going to look, combustion is a very complex reaction, and we're going to look at the very basic and very rudimentary concepts of it, because it's a very complex reaction, and we're just going to look at the general aspect. And generally, a combustion involves an oxygen reacting with another substance to create an oxide. I said oxide enough, so you guys know that oxide is a molecule, a compound containing an oxygen. And we're going to take one chemical reaction with methane, example, creating CO2 and H2O. Okay. And these guys here are reactants. In combustion, you have your oxygen reacting with your another substance to create one or more, in this case there's two more oxides. Okay, so carbon dioxide, water, is also known as dihydrogen oxide. Okay. In this example, we have a very particular case because of this very popular fuel. Fuel is something that we use to burn, right? So this fuel is also known as a hydrocarbon. Hydro from the hydrogen and carbon for the carbon. Kind of self-explanatory there. And we'll see a lot of, in most combustion, it involves these hydrocarbons. This case here is my methane and CH4. Now, in combustion reactions, there are two very general combustions. One is complete and incomplete. First, we'll go for the complete one. Complete combustion. In complete combustions, we have enough, or when oxygen is available, in sufficient amount. Sufficient is keyword here. We have complete combustion. Combustion occurs. Okay. A very general form is, if you give me a second, a very general form of a complete combustion, like I just showed you. Let's bring out the example here, sorry. CH4 plus O2, oops, wow, O4. O2 reacts with CO2 and H2O. Don't forget, you always have to balance your equations. In this case, 1, 1, 4, 2. This is 4 oxygens. Oops. Oxygens. So you gotta balance your equations. Don't forget. A very general form of writing hydrocarbons would be CXHY plus O2 CO2 plus H2O. This is a very general way to recognize this is a complete combustion because I am using up all my oxygen, getting carbon dioxide and water out of it. The X and Y determines the amount of carbons and hydrogens involved. And don't forget, after you establish what is your fuel, your hydrocarbon, you must balance it, just like I did up here. And another interesting thing when you do a complete combustion, all flames turns out to be blue. Here's my fire. Something like this. Bunsen burner, let's say. Like that. So you get your blue flames in your complete combustions. Now, in contrast, in incomplete combustions, Oops. Occurs, occurs when there isn't, sorry about that, isn't enough oxygen available. Keyword here is isn't enough. Remember when I said complete combustion, you must have a sufficient amount of oxygen to do it. In this case, there isn't enough oxygen. A good sign, a good telltale sign that tells me that I'm looking at an incomplete combustion is looking at the flame. If the flame is yellow or orange, it usually signifies that it is an incomplete combustion. So look at the candle light. It would almost mean that I have an incomplete combustion. So there's a yellow flame and also yellow orange flame, and also it produces light. That's also another thing that a complete combustion cannot do, is create light. Light is only occurring with incomplete combustions. On top of that, because it's incomplete, okay, a combustion could have, here's my hydrocarbon, let's say, and I have oxygen, which have not enough, and I create, let's say, carbon dioxide and water, and also it can produce carbon monoxide and soot, also known as elemental carbon, as a solid form. In incomplete combustions, carbon dioxide are not necessarily have to be involved or produced in the reaction. It cannot. It's a possibility. Water must always be produced regardless of what happens, because an oxygen, hydrogen must be placed somewhere. So what's possible? A possibility of products would either have just carbon monoxide or just simply carbon. Very unlikely, but you could just have carbon monoxide. So these guys have different possibilities of outcomes. Okay. It does not mean every time I have incomplete combustion I must have a carbon dioxide, water, carbon monoxide, and so I could not have carbon dioxide. Okay. And I guess that's about it for my video for combustion. And I know it's a little short, but yeah, it's nothing too heavy. We'll discuss further on in class about other different kinds of combustions. And I'll see you next time.